Et c'est reparti pour la dernière session de cette deuxième journée du World Power to X Summit. Nous allons voir avec nos panélistes, nos ultimes panélistes de la journée, de quelle manière est-ce que l'industrie liée à l'hydrogène et l'énergie liée à l'hydrogène pourrait, disons-le, révolutionner la mobilité, le secteur du transport, avec toujours cette préoccupation, cette nécessité au regard des enjeux climatiques de la planète de décarboner les différentes activités personnelles, particulières ou industrielles. Et pour animer et modérer ce panel, j'appelle sur scène à mes côtés, please welcome Mr. Naoufel El Fadil, Country Director chez EDF. Welcome, sir.
Ladies and gentlemen, good afternoon. Will hydrogen revolutionize the mobility sector? This is the question we'll try to answer in this panel. The large-scale production of green fuels will be a crucial component in decarbonizing the planet. Solving this global challenge could be done using green hydrogen directly or through other synthetic fuels. Power-to-X technology can be used to produce green hydrogen, but also synthetic methane, methanol, ammonia, kerosene, gasoline, and diesel. We expect economics to define the optimum choice for each mobility application of these different vectors. This session, which I'm honored to chair, is dedicated to discussing the increasing role green fuels will play in transitioning to a net zero carbon economy. Leading experts from around the world will share their insights about the position, opportunities, challenges, and the deployment of green fuels to achieve this decarbonization. It is my honor to welcome Mr. Nouri Shahid, General Manager Morocco at CWP Global. Mr. Eric van der Heyden, Business Manager Hydrogen at Port of Rotterdam. Mr. Salah Mehdi, Global Director Hydrogen at Howden. And Dr. Yassine Zegzouti, researcher at the Konrad Adenauer Think Tank. Thank you for joining. So to start this panel, I will pass the floor to Mr. Nouri Shahid. Mr. Nouri is an aerospace engineer who graduated from Parks College of St. Louis University. He also holds an MBA from Nottingham Trent University, has close to 30 years of experience in various business industries, ranging from the marine industry, steel processing, automotive, and finally renewable energy sector for the last 10 years. Mr. Shahid will show us which mobility applications can benefit more from green hydrogen and the determination factors for H2 development in this sector. Mr. Shahid, the floor is yours.
Thank you very much. Hope you can hear me. So without further ado, first of all, let me thank the organizers, RSN, and all the other guys that put a tremendous job in organizing this event. I did not present any presentation on our company, CWP. I strongly urge you to visit our site, cwp.global. And maybe you may have heard that we recently signed, about 10 days ago, a really important, significant deal whereby we invited a major integrated energy company, namely BP, to join us in developing and building the first truly large PTX project in Australia, which is RA. The CapEx is about $35 billion. So one of these things will really get built. And now let's look at these beautiful slides that I did not make. They were put together by my colleagues in the Sofia office. So mobility, we're just going to break it down the easy way: air, marine, and land. The love story of hydrogen and transport goes actually way back in the 50s. Let's all remember that rockets, when they showed up, were powered with liquid hydrogen. Okay? In fact, the fastest plane flying today, or stopped flying, but who has a world record flying Mach 7 is the X-15, which actually flew powered with anhydrous ammonia. Okay, what we have here is a myriad now of companies developing flying objects, from rockets to planes, subsonic, supersonic, drones, helicopters, electric planes, hydrogen fuel cell powered planes. In some cases, it's too close to call. You really do have applications whereby you can use fuel cell aircrafts and electric batteries run aircrafts like drones. It seems to appear that hydrogen is taking over the battle on drones, because now, last month, I think there was a world record where a drone flew for 5.5 hours powered with fuel cell. Okay. But again, it's too close to call, and the battle of drones and cars actually has nothing to do with the fact it's powered with hydrogen or fuel or powered by batteries. It has to do with artificial intelligence, but I'll come back. So now we're going to land mobility. So there will be applications where, in typical European city, you would just charge your car at night or when you go to the mall, and it makes absolute sense. You have cheap green energy, hopefully from your power socket. Though again, as I just mentioned, funny enough, the real value of these cars the real battle when it comes to cars, personal cars, is not whether they're powered with hydrogen or powered by battery. It has to do with whether the car can drive itself or not, just like the drone, whether it can fly itself. And Elon Musk said last week that Tesla is worth zero money if it cannot drive itself. Okay. Now, that was for the little story. If we look at heavy trucks, such as this one, mining truck, we think that hydrogen is going to take over, just powering the fuel cell and powering an electric motor, charging a battery. We can have forklifts running on hydrogen, but again, it's too close to call. You can just have a forklift whereby you plug it running on a battery and everything's fine. And we do believe that there will be a market for both, actually. Train is actually a bit the same. You don't really need hydrogen to power a train. If you have cheap electricity and a really good grid network, you just have an electric train. Now, bunkering fuels. This is the main thing when it comes to hydrogen / ammonia. In the short term, we have e-fuels, we have LNG, of course. But in the long term, really, to truly decarbonate, you need something like ammonia. If you look at Morocco right now has a bunkering fuel market of 3.2 million ton. You convert that to ammonia, it becomes 8 million ton with a little bit of growth over the next 30 years. It's 12. If you take only 50% of the market, that's 6 million. 6 million tons of ammonia is 3 times more than what OCP is buying in ammonia today. So bunkering fuel market is a significant potential business for Morocco and countries that will have cheap ammonia, which are on a coastline, ideally to service these big ships. Now, let's just all pause for a second. This is something that really struck me. In an ideal world, you would have a perfect overlap of 3 things: cheap and abundant renewable energy sources, population, meaning population density, and grid, because without the grid, transmission, distribution, nothing happens, right? And what we see here is really striking. I think God, to make things a bit tricky and more complicated for us, we see that the grid is really a photo taken from outer space at night shows you whether there's a grid or not. Very simple. It doesn't actually show you whether there's population or not, because look at the African continent. Very little light, yet 1 billion people live. And there's a lot of them living in the middle where there's no light, meaning no grid. Southeast Asia is in the same situation. Latin America a bit less, but there is in the areas of Peru. The laser, okay, yeah, thank you. So, you know, what do you do when you have renewable energy not, let's say, available? You have populations and no grid. Somehow you need to get them energy. So in places where the grid grows fast, you know, electricity will always be available for people to run their equipment or cars or whatever. But we have a lot of areas where you have a high number of population, right? They have needs and they don't have a grid, or they don't have energy, access to energy. This is where hydrogen kicks in, because instead of carrying a canister, a jerry can of fuel, you can just carry a cylinder of hydrogen, put it in your boat, power a fuel cell, go to the island, charge the, load the passenger cargo, come back, and that's it. On that island, you have no grid, no power generation. So that's when population extend much faster than grid capability, okay? In other countries like Morocco, you're driving through a neighborhood and you see that there is lighting, electricity, but no house built. Why? Because in urban planning, it says that in two years' time, there will be buildings here. So the grid comes first, okay? I think I'd like to conclude with these 4 slides. So the top one here, in the top left corner is wind. So obviously red, very windy, strong winds. The lower one, very red, is the solar irradiation. And then you overlap that with your population density map. And if you look then closer and you believe that you need both wind and solar to make cheap hydrogen, well, you see that it's actually in very hot and windy places where you don't have people that you can make cheap energy, because who would be crazy enough to live in a very windy and very sunny place, which typically would be a desert or a very harsh environment. And then the last one is just your grid. Thank you very much. Thank you.
Thank you.
Thank you, Mr. Shahid. I noted 2 essential points. First, you showed that there are already many aerial, sea, and land mobility examples using hydrogen successfully. And second, you showed us how it's important to have strong infrastructures, abundant energy to be able to deploy those green fuels worldwide. Thank you, Mr. Shahid. Now I'll pass the floor to Mr. Van der Heyden. He's business manager at Hydrogen for the Port of Rotterdam. Eric graduated with a Master of Science in Applied Physics from the Delft University of Technology, has worked for 15 years for Siemens, mainly in the energy field. Amongst others, he has worked as regional sales director in the Middle East, based in Dubai. Back in the Netherlands, he has set up and has been heading the team for Smart Grid. He's now leading the hydrogen for the Port of Rotterdam. In that role, he's responsible for jointly developing a large-scale electrolyzers project with different partners. He also represents the Port of Rotterdam in some international projects, aiming to create hydrogen import corridors towards Europe via Rotterdam. One of these projects is La Cigogne in Morocco, together with Mazen and Vopak, that he will talk about. He will also share with us his perspective on green fuels from the Port of Rotterdam's point of view. Mr. Eric, the floor is yours.
Thank you very much for this introduction. Now it's also a pleasure to be here. So I want to thank as well Irison and the organization to give us the opportunity also as Port of Rotterdam to present here, to present our hydrogen strategy of the port. and specifically also with the focus on green fuels being part of this session. Yeah, as I said, I'm business manager hydrogen. So I'm part of the hydrogen team. We have quite a big hydrogen team in the Port of Rotterdam, where I mainly focus on large-scale hydrogen production inside Rotterdam and also internationally. And I'm here together with my colleague, Monica Swanson. She's there. Okay, luckily back in time for the coffee break. She is the program manager, Hydrogen Corridors, and I'm also responsible for Morocco. Yes. First, yeah, to present Port of Rotterdam. We are the biggest port in Europe. At the moment, the 10th largest port in the world. There was a time that we were the biggest port in the world, but mainly in Asia and China, bigger ports came up. But still in Europe, we are yeah, by far a bigger port. And we don't only serve, let's say, the Netherlands, but mainly also a big part of the hinterland, mainly Germany, Belgium, and other parts. Our port in Rotterdam, it's actually a yeah, big industrial cluster of area of around 40 kilometers with more than 3,000 companies. All kind of businesses, but we are actually like a big energy port. Mainly based on fossil-based energy, because we have 3 of Europe's largest oil refineries inside the Port of Rotterdam, being one the Shell refinery at Pernis, which is the biggest refinery in Europe. And from that, we have 13% of all the energy consumed in Europe goes through our ports, and 1/3 of Germany's energy goes also through our port. So we serve also North Rhine-Westphalia, big industrial cluster in Germany, will also be served by energy via Rotterdam, by providing it currently via pipelines and barges, ships, energy mainly in a fossil way, being oil, gas, and coal. And that's also where our challenge is. We want to decarbonize with the challenge. So all these fossil-based fuels need to be replaced by renewables, and also hydrogen will play a very important role in that. Talking about green fuels and biofuels, also we are said we are the #1 bioport. So we currently have already quite some companies that are doing that are producing all kind of green fuels based on bio-based substances and waste, and also refused vegetable oils and others. And recently we also have some announcements of some companies that also are investing in Rotterdam with new companies to produce biofuels. Here to make an overview of our hydrogen strategy in Rotterdam. And again, you see here the layout of our port area. Now again, hydrogen will play a very important role. And our hydrogen strategy is based actually on 3 aspects. First, also, we have local production. We have some currently massive users of gray hydrogen, being mainly the refineries, like the refinery of Shell and BP. They use gray hydrogen and want to replace that, yeah, as quick as possible by green hydrogen. And to do that, they want to invest themselves as well in local green hydrogen production inside Rotterdam. We happen to have located to the North Sea, which is quite advantage for also for offshore wind. It's very shallow, and the Dutch government is currently rolling out a big tender scheme, up to 20 gigawatts of wind parks built up to 2030, out of which 7 gigawatts will be connected with offshore cables to the Port of Rotterdam. And where it comes to land, we have allocated a cluster where we want to facilitate companies that want to build local electrolyzers. One of them being Shell, also BP. And we have done that by making electrolyzer cluster. So making them, having the opportunity to share the infrastructure. So shared high voltage connection, shared hydrogen connection, shared dam and water production. which makes it possible for these parties to build their hydrogen plants there. One of them is being Shell, that want to build a 200 megawatt electrolyzer, which they are going to about to take FID in very soon. And the plan is it will be operated in operational in 2024, which will be more or less like the launching customer for the whole hydrogen structure for us in Rotterdam. And the second aspect, of course, is infrastructure. It's said already here before by a lot of the other speakers. Infrastructure is essential. So we jointly developed the infrastructure inside our port to have an open access backbone, first to be used locally by connecting these electrolyzers by the off-takers, being the refineries. But on the short term, it will be connected by the Dutch national backbone made by GasUnie, by the European hydrogen backbone, but also as we have a very important corridor from Rotterdam to Germany, which is currently a corridor with fossil-based fuels in pipelines. We plan to extend that with some additional corridors of pipelines, with also including hydrogen, which is called Delta Corridor. So also huge investments in infrastructure for hydrogen. Third part, and maybe also most important to mention here, is import. Yes, we have some wind, but it's by far not enough to accommodate all the electricity, to create all the hydrogen that we need. And I want to show that on this graph here. We calculated a bit that to be able to replace all the energy, we need roughly 20 megaton of hydrogen in 2050. As we think that with local production, we can go up to 2 megaton. So the biggest chunk has to come from import, as you see in the graph. And in the recent events in Europe, also this import part has been speeded up. 1 year ago, we thought around 2030, there would be the big ramp up of the imports. But now it has been put forward that we already want to be ready to receive 4 megaton of hydrogen in import by 2030. And that's also recently what we have made a commitment to the European Union, as you see the picture above, try to be able to promote that. In order to be ready to import this hydrogen, currently a lot of terminals in Rotterdam are investing to be transferred in ammonia terminals and other carriers to be able to receive this hydrogen. Here, I think you have seen a similar map like this already many times here. Luckily, they're a bit all the same, so we have the same vision. We as Rotterdam, as we know, Europe will be a huge importer of hydrogen, and Rotterdam will play a big role in that as a gateway for this hydrogen. Yeah, we want that hydrogen is there in time. So we are proactively promoting to establish these corridors of places in the world which will be exporters of hydrogen. We are in, let's say, direct proactive contact with a lot of these parties, as you see on the map. So Morocco is a very important one of that, but also Chile, Namibia, Canada, and Australia, where we are in direct dialogue with some. We have MOUs that we are in some way trying to help, to support, and to promote to get these corridors running.
1 minute.
Okay, thanks. And everybody's talking here, hydrogen transport, you need a certain carrier. In future, we think it will be also liquids. It will be maybe methanol, LOHC. But for the short term, everybody thinks like ammonia will play a big role. So that's also where we betting on in Rotterdam. Yeah, so also to establish this corridor with Morocco. As said, Morocco has a huge potential. It's quite close to Europe. So we are already for some time engaged here together with Masen, being leading party here to make the PV, wind and hydrogen. We made an alliance together with Vopak, which is also a Rotterdam-based company for which is well known for handling and storing liquid bulk like also ammonia. And Vopak has also recently announced that they are going to build a an ammonia receiving terminal inside the port of Rotterdam, together with GasUnie and Hess, which is actually a current coal terminal, which are going to transfer into an ammonia terminal. Yeah, for the aspect of green fuels, as I said, in Rotterdam, we are an important player also green fuels, and it's one of the offtake markets for hydrogen, one of the offtake markets for the hydrogen, as there are, of course, all the others to decarbonize the industry. We see that currently Rotterdam is a very attractive location for companies that want to invest or build green fuels or biofuel refineries or plants. And that has to do also simply with the availability of hydrogen, of course, as soon as possible, green hydrogen, but currently also with the hydrogen that is there already in the gray form in Rotterdam is a basis to start their business. And secondly, of course, for green fuels, apart from the hydrogen, you need the feedstock that contains, let's say, the carbon part, being it waste or other kind of biobulk. And logistics are very important for that. And Rotterdam has simply a good location for logistics to receive this bulk. Secondly, offtake of green fuels is currently based on regulations. Most of the green fuels that are currently produced are used as a byproduct to the refineries in Rotterdam, because there's a current obligation to blend in green fuels into existing fuels, and that is currently the major offtake for the green fuels. So that is it's very important to say that regulation is important here. Yeah, apart from green fuels, of course, the mobility sector will be transferred also with direct use of hydrogen, direct use of electricity, and all kinds of biofuels and green and synthetic fuels. One interesting aspect to say is we are talking about transporting hydrogen over the globe in a certain form of carrier. In the end, if you want to make a biofuel, that can act as a carrier itself. So maybe in the future, we see on the locations that are now currently exporting also that biofuels produced can be located there, but that's of course related to the availability of feedstock.
Conclusion.
I will conclude. This is just to show Neste is one of the companies inside the port of Rotterdam, and I borrowed this an examination that they did how the use and the production of green fuels will ramp up in the future. And as you can see here, everybody expects a huge ramp up after 2030 in green fuels based on all kind of availability of feedstock. So with this, I want to conclude. Also here, myself and my colleague Monica Swanson are here available at the conference. So if anyone wants to go in further discussion with us, we welcome, happy to do so. Thank you.
Thank you.
Thank you very much, Mr. van der Heyden. And do not hesitate to join Eric, who brought some very exciting ideas to the debate. So we noted the importance of having corridors towards Europe, considering the necessity of having energy coming from other countries, as Europe can't alone address its needs. We also saw some interesting ideas related to new raw materials that could help accelerating the decarbonization of the industry. Thank you very much. Now I'll pass the floor to Mr. Mehdi. Mr. Mehdi will focus his presentation on a specific technology that enables mobility at scale using hydrogen. Mr. Mehdi leads Howden's global hydrogen business segment. He has over 20 years of experience in the sector. He has delivered high-profile green and blue hydrogen, ammonia, and methanol projects, including one of the most significant projects in the world in this space. Under Mr. Mehdi's leadership, Howden has engaged in key and unique projects in this space, such as the world's largest hydrogen refueling station, the world's first green steel plant, and the world's first e-fuel plant. So please welcome Mr. Mehdi.
Thank you. Good afternoon, everyone. So I hope that you are enjoying this fantastic event Sim I'm doing, and I would like to seize this opportunity really to thank the organizers for the fantastic work actually that they have been doing in the background for this event to come with this fantastic shape. So thank you very much. So in the next few minutes, I will be covering the last bit in the hydrogen value chain puzzle. Across the last 2 days, we had companies talking about the ammonia, the hydrogen production, the electrolyzers, the fuel cells, and now here the last bit, the hydrogen compression technologies. And I will start actually from the last slide that Dr. Patrick Hendrick this morning actually ended his presentation with, saying that definitely the hydrogen compression is a key element in the hydrogen value chain and one of the major challenges that this industry faces. Having said that, it's not my intention really to use these slides to, in the first place, to speak about Howden or what we do, our capabilities. But from another angle, I would like to use this as a showcase for a successful business case for a company in this very challenging market that at our level has successfully managed to narrow, if not close, the gap that everybody's talking about. The gap between, from one side, the ambition, plans when it comes to the hydrogen, and from the other side, the challenges, the barriers, and successfully narrowed this gap and started actually to make a good business out of this, again, challenging market. So quickly, Howden was founded back in 1854. So we have been in the business for almost now 165 years. And across these years, we have been serving so many different industries as others, oil and gas, chemicals, mining, power. And actually, we have been serving the old gray hydrogen for over 100 years now. We are a global company. In principle, as I mentioned, we are a manufacturing company. We deliver, supply hydrogen compression solutions when it comes to the hydrogen market. Roughly, we are over 6,000 people operating from over 90 locations across the globe, with very large manufacturing and service capabilities across the globe in all over the key markets, as you can see, with assets installed in almost 169 countries, again, worldwide. As I mentioned, we are a manufacturing company. We do what we call air and gas handling solutions. So any equipment that can handle gas, air, or any kind of gases, including the hydrogen, this is what we do. We are a leading company in this space, anything from compressors, blowers, fans, turbines, and so on. Having said that, as I mentioned, our main offering in the hydrogen space is basically the compressors, being considered as one of the leading companies in this space. And why the compressor or the compression technologies are so important? This comes from the first challenge that we all know about the hydrogen, which is the fact that the hydrogen has a very low volumetric energy density. That's it, actually. So that means in order to get the same energy value that we would get it actually from another, fuel, natural gas or others, we have to use the hydrogen with very large volumes and at very high pressures. And this is basically the function of the compressors. And this is the reason, and potentially the only reason, that the only major equipment that sits all over the hydrogen value chain, everywhere across the hydrogen value chain, is the compressor. And this is why we say that definitely the compression solution and technologies play a key role in the hydrogen value chain now and in the future. Why we are different? Because we have very wide portfolio So far, 5 different technologies. Just to give you the flavor, the nearest competitor has only 2. And not that just this, but also Howden invented number of these technologies, like talking about the mobility. The main compression technology that everyone nowadays use is what we call the diaphragm compression technologies. And this is a technology that Howden invented over 100 years ago. The screw compressors, this is a technology Howden was actually the first company to commercialize the technology over 90 years ago. And our strategy really is that in playing in this market is we depend on definitely in the first place our advanced technologies in research and innovation, and also the global footprint. As I mentioned, we operate from over 90 locations. That means wherever the project is, our teams are there, can actually step in quickly, help our partners to make sure that they have a smooth operation without any issues. And with this wide portfolio, definitely our solutions, technologies can, be used in all the known hydrogen applications. Just a few examples, starting definitely from the main topic of the presentation today, the refueling station, the mobility. And we delivered larger number of, technologies to a larger number of refueling stations in the world, as I will elaborate later. But also blue hydrogen, Power-to-X, hydrogen pipelines, green steel, and so on. Our strategy is not just to work. We understood very well the role and how important actually this technology plays in the hydrogen projects. And this is why we adopted a different style from just being, acting as equipment supplier to acting as a partner, as a consultant. We know this technology, and we know actually how to optimize it in order to reduce the levelized cost of the hydrogen to the lowest possible levels. Being someone who has been actually, even before my time with Howden, has been working in the clean energy side, in the ammonia, in the electrolyzers, in the methanol, in the hydrogen. I'm not aware of any other company that has been actually and is involved in that large number of hydrogen projects. And I'm saying projects, not studies, projects that have been delivered, like Howden is. And not just the numbers that actually make us happy, but actually the nature of larger number of these projects. I'm talking about just as a few examples. The world's first green steel project, it's running now in Sweden. The world's first e-fuel plant in Chile, running now. The largest hydrogen underground storage project in France. And the largest hydrogen refueling station in the world in China.
1 minute.
So large number of projects have been delivered in different segments and across the world. And the message here is just to show you that the market is moving very fast in all the regions, in all the segments. A few weeks ago, we closed our first project in New Zealand. Last week, we closed our first clean fuel project in the world in the marine side. So again, moving everywhere in the globe and in all the segments, in all the industries. Successfully, with all what I have said, we managed last year to close the year with a very strong financial position, 500% year-over-year growth. Not just the past, but also the future. We managed to build a strong pipeline of hydrogen projects that will serve us and the market for the next few months, a few years, that actually 3 times what we had in less than 9 months ago. And I'm not sharing here the numbers for the sake of sharing the numbers, but actually the message that I came here today and I would like to convey is basically to encourage everyone to step in and invest in this market. This is what we need. This is what the market needs. And to tell that there are a lot of opportunities. If you have the right focus and the right plan, definitely you can make a good business as of today with all the challenges that we know. This strong financial position definitely helped us to build a very strong pipeline of what we can call the market future technologies, more advanced technologies that we know from the knowledge that we got working in different segments and different industries that these industries need, more advanced technologies everywhere. We believe in partnership, in the meaningful partnership types of relationship, because we would like actually to work with our partners to develop in principle well-integrated advanced solutions that the market and the different industries need. We are also very active and believe in the role that policies and regulations will play. And this is why we are a very active member in over 10 global and regional key hydrogen associations. So we work a lot on policies and regulations, depending also again on the experience, the knowledge that we got working in all of these projects everywhere. Myself, I chair the Hydrogen Europe Industry Group, so work also to strengthen the hydrogen economy in Europe and also globally. Talking about the mobility, my last slide, a good reference for us. As I mentioned, we delivered larger number of or solutions for larger number of hydrogen refueling stations across the world, in New Zealand, Denmark, US, across Europe, very recently New Zealand. But definitely the reference that usually like to bring is the world's largest hydrogen refueling station, almost 5 tons per day hydrogen refueling station in China that actually can serve 600 buses there. And before I close, I would like to really seize this opportunity to remind us that yes, when we talk about hydrogen, when everybody nowadays talk about hydrogen, we feel really very excited, right? Energy transition, business opportunities everywhere and for everyone. There is a room for everyone. But I would like to remind myself and everybody listening to me in the room or online that the story in the first place, actually it's not about the hydrogen. And it is not about the energy transition and definitely not about the business opportunities there. But in the first place, it's about the climate change. And the fact that we need to fight this climate change. It is in the first place, is about the next generation's right to live in a healthy and a clean environment. Thank you.
Thank you.
Thank you very much, Mr. Mehdi. Thank you for presenting us how hydrogen compressors enable harnessing and optimizing the potential of hydrogen. And thank you also for remembering us why we are doing it. Now I'll pass the floor to Mr. Zegzuti. Mr. Zegzuti will present us the opportunities and challenges of decarbonizing the mobility in the MENA region. Mr. Zegzuti obtained his PhD in biotechnology and environmental science from Qadi Ayyad University in Marrakesh. He's an expert in sustainable production and consumption, a trainer on solid and liquid waste management, and the founder of the Mawarid Association for Environment and Energy. Actually, Yassine is the research fellow of the Regional Program Energy Security and Climate Change in the Middle East and North Africa at the Konrad Adenauer Stiftung. Please welcome Mr. Yassine.
Thank you. Thank you so much for this nice introduction. I would like first to welcome the audience and also to thank the organizer and also the partner. And I'm so happy that Mr. Salah has indicated the importance of climate change. And I am representing the Konrad Adenauer Stiftung, especially regional program of climate change and energy security. So first of all, let me start by a quick introduction of our program. So we can just to before having the slides, it's like I will like convey to you what is happening on the ground with some politicians and with some MPs on the ground regarding biofuel regulation and laws. So this is our aim here.
So maybe I don't think you gave them your presentation.
I give the presentation.
It has been given.
Yeah?
Do we have it? No, we don't.
Okay. So
Where do you have it?
yeah,
You have it on your
yeah, I have it
phone.
USB. Okay, so
Okay.
I will give it to you.
You have a key?
Yeah, I have a key.
Give it to me, give it to me. I let you begin and I give them the key. Okay, sorry for this. You can maybe begin the introduction.
Okay, so as I said, our program is called the Regional Program of Energy Security and Climate Change. And one of our aim is like to bring together all the policymakers, the NGO journalists, like to find solution for this problem in the MENA region. And why we work on the MENA region? Because the MENA region...
You've got it.
Yeah, fortunately. So let's start again. So as I said, one of our main objectives is like to strengthen the development and support stability of MENA region in terms of climate change and energy security, and also promote cooperation and partnership with European Union. So one of our instruments to implement this goal is to working by cross-country and cross-regional dialogue programs such as workshop and conference. But we produce studies and policy papers. And the majority of our policy papers and studies have demonstrated that the MENA region is one of the most climate vulnerable region. So as the model of climate projection show that the temperature, as you know, is rising. And also there are a fluctuation and the intensity of the rainfall is not stable in the MENA region. And also we have sea level is rising. So this dramatic situation requires the decarbonization of many sectors. But today we are talking about the mobility, and the mobility is very important sector in the MENA region. Why? Because the transport sector in MENA region is evolving very rapidly to respond to the increasing regulatory pressure on transport emission. And for example, we have transport account of 11 to 31 of global energy emission. Secondly, many countries in the region have included a specific transport green greenhouse gases in their target indices. So they should honor their commitment. Another thing is that MENA region, major resource-rich countries are economically dependent on the oil and gas trade. So they should find like alternative. So as you know, the solution was presented by the other expert as the hydrogen, green hydrogen, all this solution. But for us, as we worked and we organized many workshops, we worked related to policies that are made by the government. We have some conclusion and some remarks to share with you. So the transition is like we will start by the opportunities that a transition to green hydrogen for transport sector could drive to economic growth through industrial diversification, new value chain activities. So we have recently published a study about desalination in the MENA region, and we have noticed that there are many desalination plants that are under construction, and there are others that have already constructed. So that means that like there's a dynamic that to pave the way for this hydrogen dynamic. Also, according to recent study by PwC, the Middle East and the North Africa region could produce about 200 million tons of green hydrogen by 2050. So it is important and it's opportunity for the region. So another point also to share with you that potential existing market and opportunity for capturing lost oil, export and demand, because especially for Gulf country, they should find alternative. And not normally the development and management and maintenance of hydrogen installation will create a sustainable job. We have also the hydrogen-related technology are reaching maturity to be commercialized with the cost continuously falling. So we have some statistics here we can share with you after. Another aspect is that hydrogen fuel cells are more promising in transport, greater energy storage, density, lower weight, and smaller space requirement. The challenges. A few countries have announced their roadmap of green hydrogen energy industry as well as hydrogen energy infrastructure, but except only some countries such as Morocco, Emirates, that have launched their strategies. Most Power-to-X technologies suffer from relatively high capital costs. And the problem that for desalination, for producing hydrogen by electrolysis, we need water. And as you know, that the region, the MENA region, is one of the regions that really scarce of water. So it's like a big challenge in the region. And also this is like a technical problem that I would share with the expert, that an estimate of 60% of stored hydrogen energy is lost in the process of packaging energy. Some suggestions. So first of all, we would like to invite experts and to explore the way of producing hydrogen by biological ways, because there are many opportunities there to produce it. As you know, we don't have feedstock in the MENA region, as it can affect the food security. So the solution is like to work with the biogenic waste. And in this kind, we can treat waste and at the same time, we can produce hydrogen. And as you know, that anaerobic digestion that can produce CO2 that we can involve in the process of Power-to-X. Another aspect also is regarding, as you know, we are struggling now with the lithium batteries. But what about the batteries that we work with hydrogen? So it's like a big challenge. At the end, we know that we can expert NGO, they cannot do all the work, but the policymakers are very important for us. That's why our program has launched an initiative called Climate Dialogue Punkt that bring together policymakers, journalists, experts. So I invite you to reach to us, maybe to exchange, to do work together. Thank you so much.
Thank you, Mr. Zegzuti. Thank you also for bringing into the debate the importance of water, specifically in our MENA region. Dear speakers, thank you very much for sharing your perspectives, the challenges, the opportunities related to the decarbonization of the mobility sector. Thank you.
Thank you to you. Thank you to the panelists. Thank you very much. You can stand up and come on the stage in front of the photographer for the picture. Thank you to the audience for your attention. Merci à toutes et à tous de nous avoir suivis tout au long de cette journée. Pour cette deuxième journée du World Power to X Summit, la session numéro 8 aura lieu donc demain matin. Vous allez continuer à explorer cet univers extraordinaire de l'hydrogène vert. Il sera notamment question de régulation et beaucoup d'autres choses à évoquer. Merci pour votre attention. Je vous souhaite une très bonne fin d'après-midi et très belle continuation de sommet. Merci.